Perfect. Okay, well, who would like to start us off this week? Crickets. Peter, you're on my right. Or you're first on my screen.
Hello, you mentioned me. Do you hear me?
Yes, I can hear you.
Ah, good. I don't know what to say. Things I think I have finally some sort of survey implemented that I'm happy with, and in the end I went under the hood with X-ray because I tried a lot of different things and wrote code and deleted code over and over again because somehow I was never really happy, and in the end I sort of wanted to avoid X-ray, so not for some reasons, but now I just jumped in with it. Maybe it makes things easier down the line. At the beginning I didn't find it very easy. Sometimes I still struggle with it, but there are some nice benefits to it, I think.
Oh.
Other than that, not much. I started with the thing, and if you have time at the end, maybe we could spend a few minutes about the transform, how you guys think you might have time when, or even if we maybe could meet Friday and look with like Bain or Miguel to have something like beforehand the meeting, what do you expect for it? Because by the time you will be online on Saturday, most of the day is gone for us over here, so it might be good to bang our heads together beforehand if there is interest.
Sure. Do you want to just talk about that now? I mean, I see some heads nodding.
Yes, well, I think I know that Dom will be interested, and Thibaut said if he's finished with writing, so I don't know what's the status there.
So
yeah, I'm very much interested. It would be great to if we can book like a specific time slot, because as you said, we're such in a different time zones, right? So when do you think everybody's going to be online and we can have a chat?
I don't know. I thought it could be good, like Friday evening for us. So for you guys, Friday morning. I don't know.
And which Friday? Because I think there's hacking on both weekends, right?
Yes, although the second weekend, because of the different time zones, Sunday is basically just presenting mostly.
Right.
Because by the time you get online on Sunday, it's basically the weekend is over for the people here. So it will have wrapped up. So it's really the first weekend, and then people who want to spend some time during the week want or can spend some time during the week, and then the Saturday, and then it's a wrap up, I would say. So I was thinking this Friday beforehand, so that we would have a bit of clearer idea what we're going to do. And my personal idea is that it's quite open. So if there is someone, because quite a couple signed up in the Slack channel, and if there is someone who just wants to make a notebook and integrate X with Y, I think that's perfectly fine. And as Miguel is around and Bain is around and some of you guys are around, they should get the help to connect the different dots. But it looks like also Miguel and Bain would be interested in doing something more long-term-ish with connecting these different things. So for this, we probably should maybe have a talk. And then I think it would be good if you could do that Friday, so we would have the full weekend for the people who have time and are interested. So I don't know, like 9-10 o'clock your time. What time do you have now?
It's currently 10:30 in Vancouver. I can wake up early, right? It's not an issue.
10:30, 10 would be.
So
it would be 9. That would be 6 here.
It's 6 p.m. where you are.
9. Your 9 would be 6 here then. Yeah, so
Okay.
there are 9 hours. I'll quickly check with Miguel, because it would sort of be important that he's around that with Bain, and then I'll put it on Slack. But let's if that's okay for you guys, something your Friday morning.
Yeah, we can do it before or after you have supper. It's really up to you. I can wake up as early as, I guess, 7. I'm not gonna wake up earlier than 7 o'clock. So cool. Yeah.
Cool.
So that would be I guess 4 earliest for your time, and then anytime after this. It's really up to you after, because it's gonna be late in your day.
Yeah, exactly. I had yesterday a call with Rowan, and I think it was 8 o'clock his time and 4 o'clock my time. I see in a different time zone than you guys.
He is, yeah. He's 1
Yeah,
hour.
that's fine. Yeah, okay.
Yeah, if 9 a.m. works, I will also try to be there. I don't know what I can commit to in terms of hacking on the weekend because I need to hack on the tutorial that I'm presenting. But I would still love to just even keep a pulse of like what's going on. So
yeah, no, I expect there will probably be people who have no time at all weekend if they still have the kids home, but maybe they can chip in an hour each day during the week. Or, I mean, it's quite broad the topic, so yeah. If you can have an eye on Slack and on that channel, and if there are folks who try to do something with SimPEG, that would be helpful, I guess, already.
Yeah, that's too bad that it's before Miguel's talk, right, on Tuesday,
Yes.
because then I'll have all the
It's
info.
before your talk as well for the ones who wanna do something with SimPEG, but it's
whatever. Yeah,
it's a learning experience. Yeah.
We don't have to do it then and now. At least get the wheels turning.
We're on it since a year, so if you get it done eventually, it's good with the SimPEG GeoSci integrations.
one thought I had on that, so for folks who are in the Swung Slack, if you're not, you should be, first of all. And then what I was thinking is, there's a lot of folks who put like the name of where they work after their name. I thought actually for the tutorials and the hacking, it might be constructive if we all just put like SimPEG behind our names so that if folks have questions or things like that, it's super obvious that like, yes, these people know SimPEG and can answer those questions.
Mm-hmm.
So if anyone's unsure how to do that, you just go in and you update your preferences, I believe. Or your...
So you update your username, I think.
Yeah.
No, how your username is displayed. Yeah.
Yes. Yeah. So you view your profile and then you can edit your profile.
Yeah.
Yeah, cool. That's gonna be fun. Okay.
So, but when is your talk? Tuesday?
Yes.
Wednesday?
Tuesday.
Yeah. It's going to be busy, but I think they're now YouTube streamed, right? So it's not actually Zoom. Yeah.
Yeah. So that's actually, I guess while we're on this topic too, that's one thing I would appreciate for the tutorial that I'm doing, which is on Tuesday from 11 Pacific till 2 p.m. Pacific. If some folks could just be on Slack, there will be a specific T20 -SimPEG channel. And so I'll try and add everyone, but if you can also add yourselves and help answer questions there. And then also potentially just keep an eye out for if there are questions that are actually worth sort of surfacing and me speaking to directly. Because I will try and keep an eye on Slack, but it's also, it could be a bit tricky depending on how many questions come in and things like that. And so if folks here could just flag and like ping me personally and just say, hey, Lindsay, this was a really good question. Would you mind speaking to it in the tutorial? I'd really appreciate that. Because I think it will hopefully help make things a bit more engaging, is to say, so-and-so asked this question, that's a great question, and then speak to that. But yeah, I will need support with that. Cool. Who would like to go next? Devin, you've got some notes in there?
Yeah, I mean, I'm just working away at the 1D problem, so I've more or less figured out the kind of the local 1D forward modeling and inversion, and kind of set up a more SimPEG-like source and receiver class, and really made it quite generalizable, and played around with waveforms and things like that. So I'm kind of wrapping up the single sounding, and I'll be moving to the stitched 1D problem and trying to get that to work. So I think once I get to that point, I'll probably summarize some things. I think there's some group decisions that need to be made about kind of the class structure and what properties are assigned to which objects. So I'm not going to go too far in a single direction without feedback. I think that's probably a good idea. Yeah, things look good so far.
Excellent.
Just, yeah.
Well, thanks, Devin. Yeah, feel free to ping when it's worth sort of getting input, and we can all take a look. Cool. Dom.
Well, I did the PR, right? That you've noticed that the the 1D IRLS was giving primary results. So that's the PR, the pull request. I don't know, was it merged in? You accepted it, right, this morning?
I accepted it. Joe, do we want to? I guess we don't really need to bump a version on this. There'll be other stuff coming in.
Yeah, it's really just touching the tutorial itself. It's not really going into the code, right? So it's really minor.
Okay. Can I just hit merge?
Yeah, go for it. I don't have the button.
Merged. Cool.
There we go.
Thanks for doing that, Dom. That's much appreciated, because yeah, it was a bit of a funky inversion result. So.
Yeah. Other than that, I'm still working on. I had like GUIs to invert 1D code and graph mag, and now I'm kind of trying to consolidate everything in a single GUI, and that kind of makes me think of like all the other methods that are gonna come in. How to organize master GUIs and drivers and all that stuff. So that's what I've been working on recently, and yeah, I guess transform. What do you need from me? Like so. We inverted Raglan, right? It looks all right. So what? Do you still think that you want to flip the camera to me, or you should just give it? I think you should just do it. But
at this point, I'm thinking that we might just focus in on Sentry. With 3
okay.
hours, I'm realizing probably
it's too much.
much. But if you do have a notebook that like we could even distribute as a part of that, that would be great. But if not, that's also fine. I mean, I think so one of the things that I was thinking would be pretty cool to do is we're going to distribute all of the lines of the Sentry data, but only walk through one of them, is basically to then ask if folks want to run inversions on all of these and send us like a link to their notebook and their inversion results. And we can sort of get a whole suite of different models from everyone who's participated. And so we could also do that with Raglan if we've got a tutorial to go off of, but I don't think it's not super critical.
No, I mean, mostly I think your focus is mostly on the framework and the back end of it. So it's not going to bring anything new to the table. It's just going to make things longer and more complicated. I'm totally fine there. Just assisting. Yeah.
No, thanks, Tom. Yeah, and I mean, down the line, we can maybe turn Raglan into a tutorial, because it's nice having some field example ones that we can include in the docs, but I don't think there's any pressure to get that done like this week. So.
Right on. Okay, so I'll focus on our hackathon with GenFi.
That sounds great. I'm really excited to see what comes out of that. Thibaut.
Making progress, but yeah, I think it's getting there. Like, yeah. So thanks for your review on the joint paper. So yeah, I went through that. I have a working draft of the thesis that I need to reread, and yeah, and Dom, I resubmit. You probably seen I resubmitted the TKC paper too. So. Not easy working on 2 papers and 1 thesis all at the same time.
Nicely done.
So yeah, I don't know for the hackathon with GenPy, I will be super interested, but I admit that it's not made it to at the top of my priority list at the moment.
No problem. That is understandable. Cool. Thanks, Thibaut. John.
Yeah, actually, I've been up to quite a few things. Lots of memory management, so I've had to slow down a little bit of code to just try and get things done. I found some interesting things with Paradiso, though. I don't know if I can share my screen. I have the problem up, and I can just kind of show. I can share screen. Okay. Yeah.
Should be able to.
Oh, there it is. Share button there. Okay, sorry. Can you see my screen?
Mm-hmm.
Okay. Okay, so yeah, this is our big computer. I've got a terabyte of RAM, lots of cores, lots of things to play with here. So when I originally went through, I was just going to make the J matrix without doing the chunking that we introduced there, Dom. Just because I thought, oh, I have all the RAM, I don't need to chunk it up. But if I don't do that, like the problem is pretty big. Like I got 500,000 data by 2.3 million active cells. But when I try to generate for the first receiver set there, it has about 900 receivers. So if I try to make the number of active cells by the receivers, when it goes to do the, where is that right here? Oh, if you just do the AINF times the DF-DUT all at once, Paradiso just crashes. There's no error messages, no nothing. Yeah, it was kind of unfortunate because it kept happening. It took me a while to debug to find it was just that. So then I thought, oh, well, I'll just throw the chunking at it that we introduced there, Dom, and now it works. So if it seems to be a limit, I don't know, or something with Paradiso where it tries to check that matrix, and if it's too big, it just throws an error.
I think there's in PyMod solver, there's an open issue on that problem.
Oh.
That
okay.
if the memory runs out for Paradiso, it just, yeah.
But I have like a terabyte of RAM, like I don't see, and I'm only running maybe at average rate, I'd say about 240 gigs of RAM, and then it tries to do that, and then like, that's hard to believe that I'm using up all that RAM, but maybe.
It might be an internal one.
Oh, okay.
And you know, the Paradiso solver we use is from what year, Lindsay? 2011 or 2000?
Yeah, it is the older one. We don't have access to the most recent one, unfortunately.
So there might be tighter limits than you would expect in 2020 on the one we have. So yeah.
Okay.
But what happens, like, let's say, rather than putting a matrix, like if you just put a vector, is that still a problem?
I haven't just tried doing the vector. I was just doing that inverse, solving for the inverse, and then it just cuts out. So I haven't tried just putting that times a vector. Is that what you're saying, Sluggy? Sorry?
Right, because I don't really, the main cost, I guess, is the factorization. So, I mean, like the back solve is like, it's pretty cheap. So I'm not 100% sure, like there could be a problem, but I think the main problem should be the factorization. So if it can handle like a single matrix vector product, like a in vector, and in that case, I think 2 million cells seems not that big. So like 1 terabyte should be enough. So my guess, like if you, like there could be potentially a problem if you're putting really large right inside, and there can potentially be a memory issue because we're not 100% sure how that part is handled.
Oh.
But if you can handle like just matrix vector, like the AINF multiplied by vector, then I think you could be like a little bit smarter, because rather than just solving once, you can just iterate over.
Yeah, so that's what I've done by introducing those chunks, is just breaking it down so that it only solves a smaller matrix, I guess, of each.
Right.
Or we could do the vector, like you're saying,
Right.
Just by each one.
Yeah. It was a bit slower when like we tested before, because if you just looping over versus like actually assigning a full matrix. Yeah. Assigning a matrix was a bit faster for backsolve. So
that's what John is doing. So he's basically, instead of doing each one by one in a loop, he's just grabbing a small matrix, these small block matrices.
Chunk of that.
He's just chunking those. Yeah.
Right. So there seems like then potential issue is actually like if you assign a really large matrix, then that could potentially be a problem.
And that's where there are rows there. So yeah, if it's too large, you get a problem. I've also been working on that GUI as well. I don't know, is my screen still shared? Sorry.
Sorry, I think Joe was trying to say something, but I couldn't.
Oh, sorry.
Realized my microphone was hooked up.
Oh.
I feel like this is a good use case for in-place solutions, because as long as you can like store it on the right-hand side, you can overwrite that as you're doing the solution. So you could probably potentially handle larger and larger right-hand sides. Because right now what PyMat Solver is doing is it creates like by default, it'll just create another array exactly the same size as your right-hand side. It doubles the memory right there. As far as time taking to do factorizations and solving, like if you're factorizing it ahead of time and you're doing a lot of right-hand sides, it takes a lot longer to solve it than it does to factorize it. There's definitely a lot of issues with PyMat Solver or the PyMKL implementation that it uses, because it doesn't throw many good errors. It doesn't give you many good error warnings. It's just something that I've talked about before, trying to get a better MKL wrap or Paradiso wrapper for MKLs, so where we can handle those type of errors and catch them, and then do a few more operations that we can do and take advantage of some things like that, like in-place solutions and whatnot.
Okay.
So Joe, that's more on a problem on the PyMat Solver side. Is that right?
I think it's on PyMKL side. I think that's what it is.
Okay. It's like I think the original Paradiso actually have that option, right? Because you can
it
set
has
that
those options.
in
They're just not exposed in PyMKL, I think.
Oh, okay.
And the error handling is not the best.
Yeah. Yeah, nothing gets thrown at that. I had to hunt for that just to see that it was that. But yeah. Is my screen still being shared? Sorry.
No.
Oh,
but
okay.
you work around it's right so far. I think John's just drew that. I mean, it's kind of a compromise between a full for loop and a memory crash.
Yeah, and I even found if I'm trying to save each of those matrices to Dask, I still run out of, or if I'm just trying to sum all those into a Dask array, I'm still hitting over the limit too on RAM. So I think if you're doing that in parallel, it's just loading them all in and then overloading my RAM. So right now I'm just saving everything to disk, and then I'm just gonna pull everything iteratively. This seems to be the way it's gonna have to be done. And then the problem onto the MT, I've running a big sensitivity on that one, which is about 500,000 cells by 480 stations. That's I've got about a frequency for all components, all stations at about 8 hours. That's about as fast as I can get it. I don't know. I'm parallelizing over station. Maybe at that size, doing it over component or something would be better. Testing it at small scale, I found that going over receivers was the best. But yeah, that's a big problem, and almost might have to start dividing it in by frequency and sending that to a node, like a node server, and solve per frequency and parallelize over that, and then sub underneath those. Something I might get into in the next little bit here, because it's taking a while.
So you still haven't tiled, right? We're not tiling anything. You're doing full mesh for each. Yeah. So we
full tensor mesh too. So
we need to go back to this and start tiling, because that's going to be your biggest saving, right?
Yeah.
Your factor is going to be much smaller.
But as it stands, that's as far as I've got it right now.
Have you started noticing, I'm working on this because a bunch of people are starting to, they want to run like huge terabyte problems like you are, and then Dask for some reason starts idling after a certain level, like all your CPUs are firing up, and then you have an idle time, it can go for like a few seconds where nothing happens.
Yeah, I've just been noticing that here in the last week. All of a sudden it just stops, and I don't know. I was thinking when it's happening in the operation to Czar. I thought maybe there's something in there that's just single threaded, but I don't know. As soon as I write to Czar, you can see the blip when it writes, and it's so quick. So I can't see why it's sitting there, just spinning.
I think this might be in the CG, like in the Gauss-Newton iterations. I only to run it and debug, but we need to figure it out, because basically the processors are idling most of the time. So that means nothing's happening, right?
Do you have access to the Dask task stream and like that dashboard where you can view where task is? Have you seen that?
Yeah, I do try to use it, but the thing is that we don't get the same parallelization if we run it in a notebook versus if we run it in a script. Like we get like overhead just using the graph, so it's kind of hard to. It's not super easy, but yeah, that's one option for sure.
Interesting.
Yeah, definitely have to look back at that. And yeah, I've just been working on that GUI. I pretty much have it done. It's pretty slick. So I have a whole bunch of like, I guess DC and IP server code kind of thing, so that you send it just a JSON file as the config file, and yeah, it'll run locally on another resource. Yeah, actually, I was wondering if I can get some SimPEG icons so that I can put into the app, because we're eventually thinking that we could, like, the clients will have it and we could push. We'll be like, oh, new inversion ready, and it'll be like a little SimPEG icon just to keep everything there so everybody knows what it's powered by and whatnot.
Oh, awesome! Yeah, I can send you
Yeah.
the high res and is a PNG good enough, or you want the Illustrator?
PNG would be good, that or ICO or anything like that. Yeah.
We can do that.
Yeah. And then the next goal, Dom, is we're going to have a nice little output so the client can put it to the Geo5 file and put it into Mira.
My boss is going to be happy.
But yeah.
John, I hear that like are people actually going to run the inversion? Is that the the scope, or maybe not?
It's not in the scope right now. Right now, it's just for us locally, and then we would just push the results.
Gotcha.
But until we can get some serious resources, I don't know. I just don't see that kind of plausible.
Just curious.
Yeah.
Are you going to show us the front end?
Yeah, sure. It's a little cheesy, but my UI skills aren't the best.
That's hard. That's hard things to do.
Oh, is it ever? Yeah, so just a little simple interface here, and our guys can log in. Oh. All right. Yeah, so it's simple login. Your sessions are all stored on a cloud per se, whatever you want to call it. Yeah, it's simple thing. So if all those are there, if you want to start a new session, you can just name your sessions here. Inversion type. That's what I thought, like maybe little SimPEG icons here would be kind of cool. Just powered by. We'll have forward and then processing. We're just going to have a lot of our stuff live under here, so it's easy to pass around under our hood here. Inversion types, and then just a main interface for just unconstrained inversion kind of thing. We're not looking to be too fancy, so something quick that are even maybe in the field. Some guys can check their data if we have bad connection and they have to do it from there. They can process the data and send it into here. You can load it locally, or you can have, there's going to be a path on our file server so that you don't have to load. Yeah, set all your options. I tried to generalize it enough, but I guess over in the additional inputs is kind of where you have your conductivity model, because not everything will have that. So I just kind of threw this into like a mismatch area. Yeah. Then you can choose our resource. Right now we just have 4 resources available. Our big machines are, of course, are named after
great names.
Yeah. Yeah. So when you can submit your inversion and it'll update in real time, but usually ours are so long. Yeah, you'll disconnect and you'll come back and visit in a little bit here. Sorry, little bug I have to get rid of there. But you can go back to your previous session. Say you ran or you started the inversion yesterday and you want to come check how it's doing. You can request the inversion log, and then it'll, yeah, pretty much outputs what you guys have in that directive output. It pretty much just looks for that file and then sends it back to you. Yeah, and tells the inversion is complete. So then we can get the model, or we can choose one of the iterations, get our residuals, like a dstat file that has our residuals in it that you can compare to our databases. Yeah, just a bunch of little cool things. This is just the front end, and most of the work was on the back end. But the front end is just all UI available, so it's a little cheesy, but this is the best I can do right now.
Oh, that's great, man. Diaz errors, eh? What is Diaz errors? There's a secret sauce.
Well, it's well, pretty much is just more like the data wise, the error on the data. So it's like stability of the on time, how well the VS fit the Coco curves. Actually, Soggy's stretch exponential. That's what we compare or measure our error with. See how well those fit. Yeah. So I have, and then all that is written in Python too. So if we ever need like interface stuff, I've got a lot of code written because everything's prototyped in Python. So yeah, if we need anything, those server logs, I can push them and put them anywhere. Or if anybody needs ideas, I know I'm not a great UI guy, but I know the starts of it.
I know, man.
It's like how complicated it is. Like if you want to switch it, like not your server, let's say you want to use like AWS, for instance, like would it be pretty straightforward to be extended like that?
It shouldn't be too bad. It would I just need to know, I guess, the communication with that server. Yeah, what kind of syntax it responds to, like what's the requests and what are the, I guess, I don't know, parameters or just things that you can access and talk to it.
Okay.
Working on the my GUIs, when you get to the GA side, I started using the comments. Create a folder and put comments so you can stack your JSON file right there instead of living on file. It's actually
really?
pretty useful. So we can look at it.
Yeah, that'd be cool.
And save all your iterations as comments, right, on your inversion folder. So then you don't need to look at the print. You can just store it all as string and then reload it as a JSON after. Yeah.
Reload as a JSON. Oh yeah, that's brilliant.
So yeah, when you're there, let's talk.
Okay, for sure. Yeah, that's cool.
GeoSci.xyz is on PyPy now.
Yeah, I saw that. Yeah. I was like, yes,
Nice.
it's gonna make it even easier. Yeah. All right, right on. Yeah, that's all for me though.
And Dom, actually, once you've got it on PyPy, it's actually pretty straightforward to get things on Conda-Forge. You can actually build the Conda-Forge package from PyPy. So if you have questions about that, feel free to ping, because it's nice to have those options.
Yeah, that's a good idea. The head like software person at Mira really wanted me to use Poetry to manage dependencies. And Conda doesn't behave with Poetry, but I guess if we can do it through PyPy, then yeah, that would work. Anyway, details.
Sure. Sagi, do you have any updates you'd like to share?
Nothing particular. I worked a little bit on the Sentry deposit data. So it was kind of fun to revisit, like, I don't know, 20 years ago. Historical data, but yeah, I was surprised that we can get pretty similar result from 20 years ago. So I had to kind of fine tune what the parameters were, but we got pretty similar result of like old DCI-P2D result. So I think Lindsay will use that in the transform workshop. And yeah, I also tested with Dom's sparse inversion. Not sure that I can have an image, but I can show you guys later. But we can actually get pretty good match with like a thin vein they were trying to image. So yeah, I'm actually it was actually pretty fun, and we ended up inverting in 3D. So yeah, potentially could be.
Are you doing the same trick that you're doing with the 1D inversion? You first do
a
ref
right.
and then you.
No, not for this one. Like, so this one was pretty simple. Like chargeability inversion, you have pretty good idea about the background. So it's almost binary, like sort of inversion. So I didn't have to do that. So it was actually even simpler.
So it was on the chargeability that you did it. What about the connectivity?
Right. Like the resistivity was not particularly useful. So I also did that. So I also did the sparse inversion. It kind of like you have to carefully choose the background resistivity. But I think the like kind of just doing a first step smooth inversion and picking whatever maximum likelihood value of your distribution. I mean, it's actually a pretty good way to go. Anyway, so nothing really particular. But,
well, thanks for doing that, Saki. I really appreciate it.
Yeah. With other thing, when we working with Lindsay's the example notebook, we found like a number of KY was a bit of a problem. So I think there was a bit of accuracy issue. I'm not sure what happened because I sort of tested before, like about sort of 5%-ish error. But it was actually just showing us more than 5%, like 10%-ish, especially at the near surface, like a small n spacing. So I had to increase the number of KY in the 2.5D code. So I'm not sure. Dieter, you probably have a better idea. So like this is same like a Hankel transform types of problem, like the basis function is cosine. So what we did is very brute force like a trapezoidal. So we just discretized in like logarithmically and then just did the trapezoidal. So if you probably have much better idea that how we can kind of optimize that process. So it'll be kind of interesting to hear your thoughts on that.
Yes, I saw your discussion, I think, on Slack, right? But I think I would have to look at it. I can't picture myself what is actually the thing, because I think you mentioned, or Joe, then maybe another DLF. So yeah, I don't know what is the origin of it.
It's a spatial like a Hankel transform, but it's a space domain y, like ky to y, and it's a cosine transform.
Oh.
So I think the one easy way, as you do, like like basically before we did the 15 ky value evaluation, but we can actually do a spline interpolation in between. And I think as you do, so I think that's probably better, because like now what we had to do, we had to just increase the number of ky that we're computing, which will increase our computation cost. So
yeah,
if you can just like leave with about 15 ky, that'll be pretty good.
But if you drop me a link, if there is something on a report that I can look at, then
yeah, we'll
increase it, Sagi? In order to get, let's say, 5% accuracy, how many KYs were you needing?
Like it was twice, so 15, 30. I think you may not need that much, but I think 30 was like sort of like very safe number of KY that working pretty well for that example.
So I was playing around with this a little bit more today, and last night I just got into my head looking up different quadrature rules. Essentially what we're doing is an integral from 0 to infinity of a function times cosine.
Correct.
And it's just at one free, like we're just doing that integral. Essentially though, the trapezoidal rule is probably like the worst thing we can do. Generally, trapezoid is like the worst way.
Yeah, easy, but very brute force. Correct.
But easy would be the Gauss quadrature, right? The Legendre, however.
Yeah, I just started playing around with that, like just now, like within the last like 5-10 minutes, just doing a Legendre Gauss quadrature approximation to it, and it seems to work a lot better.
Because they're usually, like I use that for the finite length dipole approximation, and usually 3 points are enough. 5 might be a bit better, and more than 5 there is no improvement anymore.
Yeah, I was playing around with this for the example that Lindsay had sent, and it's a mixture of even like at 15 points with the same kind of area that we were getting, I was getting kind of similar accuracy, and I can kind of show what was going on here in a second. I have it up here. Let me restart it.
So this was your notebook, right, Lindsay?
Yeah.
Okay. I can get into it here. Okay. So right now, say 15, and I'm going to use the Gauss quadrature rule that I just implemented really quick. So the rate, it should be about 135 overall. So just using 15, we get something close to that, right? Before, so this is the range that we would be getting. So it'd be 138 to 152.
I wonder what's if that could be one of the cause where that Sarah was having such an issue with her,
I
with her
think
forward.
if we did like Soggy had suggested, increase this to 30, it doubles. Obviously, it doubles the computation time. It will double everything. And we still get 127 to 140. So my inkling is probably just leave it set at that. I don't know. We could increase this to 20 and get it a little bit nicer. But I still think that the idea is that we should essentially not be using the midpoint rule.
All right, and for the long offset, you might be getting into the territory of like boundary conditions or whatnot, right? Depending how far you've added. So it's not surprising that you're.
I also noticed that it changed based on the. So we're doing it right now from like the wave numbers are between like 10 to the -4 to 10 to the 1. So if you go a little bit lower, it gets, if you go 10 to the -5 and 10 to the 1, it does a little bit better at the long offsets. But it requires a little bit more. So like the weights, I mean, ideally, the weights would be dependent on like the source receiver offsets, but it's really hard to do that. It's much easier just to like throw it all at once. Like give everything the same weight. I think my point is, at least using the Gauss quadrature, it's a lot more accurate than midpoint rule.
Yeah.
And then I think I put in there, I'd like to, we can just expose the NKYs for people to play with and see if therefore, if it needs to get changed, it can, but we'll leave it defaulted. I mean, I don't know, 20, 15, I think it depends on the problem.
Yeah, I like that that plan, Joe. It'd be kind of nice to be able to have some control over the KY, and yeah, Gaussian quadrature is much more accurate than what you're using before.
Do you know, Joe, if or Sagi, was there ever an implementation of the old filter ways of working with this, with the Gauche filters or the Anderson filters? I think the initial DC IP may have been coded up that way. And then you can get by with, I don't know, 11 or something like that worked for a variety of circumstances. I'm not sure whether that is just like so ancient technology that nobody looks at it anymore, or if that was
I think that was actually what I was exactly asking to Dieter. So Dieter has a lot of like a sort of flexibility on that part, kind of even like designing of filters and stuff. So I think he's got a lot of tools that we can do that. But what I wasn't sure, like he may not have exactly kind of like exact filter that we would like to use. So we probably need to do something on that.
No, yeah, it would in a way then depend how much time you have, and you could try to design a new filter. As long as you have a theoretical transform pair, you could do that. But then that would be a mini research project.
I mean, we can take a look at UBC code. I think if this was actually basically using 11 coefficient, I think what we all need is just that values, and we can use that as a weight for integration.
It'd be worthwhile looking up and trying that, and also seeing what other things have been done. I mean, certainly that whole that filtering approach works remarkably well in some really strange circumstances.
Doug, what were the filters?
Pardon me?
What were the names of the filters?
Well, they initially used to be called gauche filters. He was the person that did the initial work on GeoSci. Anderson then did, this was Walt Anderson at USGS many years ago. And then he had some, very nice sets of coefficients for oscillatory infinite functions.
Yes, it's the same. It's the same we use for our Fourier and Hankel transforms. Just in the beginning of the filters, exactly they did Wenner to Schlumberger filtering and backwards and all these type of things with 6 and 10 and 11 and 15 points. Yeah, I don't think that is done much these days. It's too but it would be interesting. But I personally only have the experience with the Hankel and Fourier transforms, not with any type conversion. But it's the same principle in the end.
Joe, do you have other updates you want to chat about?
I'm just trying to think. I don't know. It's been really. I had an odd day yesterday where I got like really caught up in this quadrature stuff, and my brain is stuck on that right now.
That is totally fair.
Let's see. I've been working on a few papers for my thesis at the moment. I've been trying to figure out why the discretized 4.11 never is not compiling on Anaconda, like on the Conda Forge thing. I've been looking into that, try to figure that out. Still not quite sure. Because I don't think, it didn't seem like anything really big changed between them where they couldn't, because 4.10 still compiles, but 4.11 doesn't.
Oh, that's strange.
Yeah, I didn't think any like the big, I'm gonna have to look up again and see if the requirements changed or anything, but yeah. I didn't think they did. Yeah, I've been playing.
At some point you dropped Matplotlib, but that might have been earlier.
Yeah, I'm gonna have to check. I'll check.
Doug, do you have any updates?
Nope. Looking forward to Transform.
I'm a bit nervous about this. I think it's coming together. Yeah, so I think it's coming together. I can give Joe briefly showed the notebook, and I can give a quick overview of like what I'm thinking, and then I'll definitely appreciate feedback and probably be sending this out to all of you for a review. One of the things I would like, oh wait, I'm on the wrong version of SimPEG. Let me fix that before. Oops. Okay, I think now we're in the right place. Perfect, okay. Can you all see that? Yeah, okay. So I mean, Joe showed this already, so I'll just give a quick overview. So
I breezed through it.
Yes, absolutely. It was the rapid fire tour.
I was trying to steal me thunder.
Yes, no, that's all right. You are always welcome to. Okay, so we'll give a bit of background on the Century deposit, and so Doug is on the hook for helping me with that. And then wanted to give just a bit of motivation. So I grabbed the IP inversion results from the Mutton paper that was done with the UBC code and basically say, okay, like, can we actually replicate this results? And maybe update the color bar. So we'll walk through the dependencies. I'll talk just briefly about sort of some of the things that are in the SimPEG ecosystem and how stuff is broken down, like discretize and PyMat solver and such. So we'll go ahead and import the things and set a nice font size. I'll talk a little bit about what the data are. So we're doing a dipole survey, show where the data are. So each of these directories contains some data. So I only grabbed, well, I cleaned this up a little bit from what was in the Dropbox because there's a lot of extra files and things like that. But what I did preserve is we've got the observation files for both the DC, which is the POT for potential, and then IP. And then there's the UBC results, both for the DC and the IP. So then I wanted to show, like, actually just what is the data file. So now we're actually just looking at the data file, and we can see there's a comment line, then there's the number of sources, this are flags, and then we've got the A electrode, B electrode, and number of receivers, and then M, N, datum, and standard deviation, and that's just repeated. So then I wrote a little function to actually go in and load those data, and I'll walk through this. I mean, so I know we've got lots of this basically in the IODC, but I thought it was constructive to actually just like start from scratch and like, here's a data file, and we're gonna load that in. And so what this function is gonna do is then give us back a dictionary. So we'll get the A locations, B locations, M locations, and the observed data, standard deviations, and the number of sources. And then as we run it, I just printed out some stuff to sort of sanity check that what we're doing makes sense. So we've got the number of sources, which is 27. At source 0, we've got the A location, B location, and 2 receivers. And that should be the same as what we saw at the top up here. So, but then if we go and actually look at sort of what's in that dictionary, I've got a NumPy array of the A locations and B locations. And then the M, N, and observed data and standard deviations are all lists. And so the way that that's all organized is here we've got, like, you know, a single A location for each of the sources. But then we look, for example, if we look at the M locations, now each entry in the list is an array of M locations associated with that given source. So everything is in the order of the sources. Yeah, we can see we've got 27. Okay, so then we go and I'll show what the SimPEG survey is like. So talking about creating a receiver. So we've got a dipole that's got M locations and N locations. So you'll see actually in SimPEG, Joe and I and Sagi have been having some discussions on a few of the issues just about naming and things like that. So this is now a slightly more PEP8 name than the capital M, which we had before. It'll still all be backwards compatible, but nicer for the tutorial to show nice names. Build up the receiver list, build up the source, and then build up the survey. And so I'll, of course, walk through what that looks like. And then I talk a bit about the data class and basically just say, you know, we're basically wrapping or unwrapping everything the same way as what we do with the survey. So it's source 1, receiver 2, etc. And because that's exactly how we read it in, we can just stack both the observed data and the standard deviations. Then we'll plot up the pseudo section, so that's voltages. I've got a little widget to just show how pseudo sections are built. And so the way that we're actually visualizing the data, and then show the apparent resistivity. Oops. Then we'll go through, we can look at a histogram of the data, and from that, use that as a way to estimate a background model. So there's a few different ways we could think of doing that. We could do the mean if we look in logarithmically, or in this case, I chose to do the median, or you could alternatively go and pick the maximum likelihood. We can take a look. I mean, none of these give drastically different results. So the median is 135. the mean is 148. So it's not a hugely different result. And so that's one thing you could play with.
Hey, Lindsay.
Yeah.
Can you go back up to the pseudo section for a second?
Yeah.
Like, is it flipped in some way? Usually I'm used to it kind of coming in this way. Is there sort of some data that were removed, or?
So there might have been some data that were removed. That's actually partially why I made this widget, is to convince myself that I hadn't screwed up the, that there wasn't a bug or that I hadn't screwed something up. And so in this case, yes, normally you would see something that looks like that, but some of the data were removed.
Okay, no, that's great. That's a good explanation.
Cool. Okay, so that takes us through just like what are the data, and then we'll set up the forward simulation. So I'll talk through in this case, and this is in one particular area where I'd really appreciate thoughts and input, because I don't want to go too far into like finite volume and discretizing stuff, but want to give just enough detail so folks know what are some of the important decision factors in designing a mesh. So in particular, boundary conditions is an important one. But also when visualizing stuff, if we visualize fields or fluxes, you need to know where they live. So we'll go through, we'll design a mesh, and I'll talk through, and I will talk through basically just some of those decision points. That should work. We visualize that, and then I talk a bit about constructing the forward simulation, using this figure as a bit of motivation for the X map for the mappings, is that we have resistivity that varies somewhat logarithmically, and also it's positive. So we'll talk through just like what some of those things are, set up and run a simple forward simulation for the background model. And then this is where that discussion came about with understanding the pseudo section and what was going on there. And show basically that that's a way of checking your mesh design. So right now we're within basically 5% error using the 30Ks. And so if we've got 5% or greater errors on our data, then this is good enough. Okay, so that walks us through just basically the data, and now we can run a forward simulation. So what I was thinking next, and this is not implemented yet, is to do some sort of like a brief visualization of fields and fluxes, just so folks can get a sense of currents and things like that. Because I think that was actually an extremely constructive thing, and folks got pretty excited when we gave the BCGS talk that you can actually like look at the currents in the earth. So I was thinking to show some of that, and then go through and start from a synthetic model and walk through some of the important choices in inversion. So talking about the alphas, the beta, our misfits and uncertainties, assignments and things like that, to give folks a chance to just like play around with a synthetic inversion. For that, I was thinking basically just maybe like a layer and 2 blocks might be useful, you know, something complex enough that there's a bit of interest and intrigue, but not overly complicated. And then go through and invert then the field data. Yeah, so I don't know what folks think of that flow, or if that kind of works.
That looks great. I mean, you have a lot of content. You'll be able to take your time, 3 hours. It's going to go fast, but yeah, you have lots. I think if you could do a synthetic, I would probably just put a conductor and a resistor, you know, but separated, and then you will see the currents and everything. Because the thing with layers, like it's fine, you know, it's like, you know, it's interesting academically, but all it's going to do is just it's going to shield your currents. So if you want to be able to talk about resistor and conductor, just having it in a half space is probably the easiest.
That's fair. That's fair. One question I have, so right now, the way this is unfolding, it looks like I'm just going to have one giant notebook for a 3-hour tutorial. But I don't actually know if there's a clean way to break it up. Do folks have concerns about just like, we just work in one giant notebook? Or do you think it would be helpful if I try and break this up?
Yeah, I think I personally like breaking apart.
Yeah.
Because sometimes like you may want to rerun like from the start, because like things can go wrong.
Yeah.
Like especially like the receiver class, it actually stores the PMH. Once you change the mesh size, then like you have some problems. So yeah, I think there's some sort of like in the code side, there could be potential problems, and you may not want to. Because say if you have a small bits of notebooks that you can like rerun easily, I think that's probably easier.
Okay. That sounds good. So maybe go ahead.
I was going to say just, yeah, whatever you do, I just think it's good to do some form of recap and show where you are in the presentation before you move to the next thing. So as long as you're good about wrapping up this chunk before moving to the next chunk, so that people know where they are in the span of this 3-hour presentation, I think that would be pretty important.
Thanks, Deb. That's a good point.
Are you going to like kind of do that comparison with the like a previous result? Is that what? Okay. So that'll be sort of your first like a notebook then, like a kind of walk through all the like some of the details and basically run like without maybe explaining too much and see if you can like show like you can get the similar result. Is that sort of the start?
That's a good point. So I'm not actually sure. I was in some ways thinking to basically get to this point where now we can forward simulate and then sort of take a detour and go focus on the synthetic before coming back to the field inversion. But we could actually basically just go and run through everything.
I think I would, like if I'm doing, I would do that. Like just kind of run things. I mean, you don't have to explain everything there, but just like show you can run it. You can get the sort of similar result that are reproducible from 20 years ago. And now you can go back, okay, but I mean, this is field data. We don't really know what's, like there could be a lot of uncertainty. So, I mean, it'll give a bit of motivation to, okay, let's work with synthetic and see if, what we can get out of it.
Yeah.
Yeah, maybe. Just a thought.
That's a good idea. And at the end, probably just do a side-by-side between your synthetic and your true, and then just to people to have an eye, to have a visual, comparison between like what we should expect in the best case scenario versus what we're getting in the case study, and then be able to like talk about model uncertainty. Just a side-by-side picture, right? Because you're gonna have both.
Yeah.
Another thing that you probably need to think about, you also need to introduce IP. So you probably need to think about like, are you going to introduce that with the synthetic? Like kind of, you need to kind of choose when that comes in. I think that in terms of like an impact, that IP image is pretty impactful, and you got pretty good story behind. So yeah, I'm not, at the moment, I'm not 100% sure what's the sort of the best way to go, because it's a little bit complicated. But yeah, you need to decide when that comes in.
That's a good point. Do you think there's any visuals that I can show for IP for the physics to get folks connected with that? I mean, I can look back at what we've done in the disk and such, but I don't know if there's anything that comes to mind that's like, this is a really impactful. I'm especially thinking sort of in 2D space, not just.
You mean in the physics side or like the field data?
Well, I guess connecting the physics side to the field data. Because we don't have sort of the same idea of an app like where you can move the electrodes around and sort of see currents. We don't have an analog of that with IP.
We actually, like Dom and I wrote like a small section in EM GeoSci a long time ago. So it's actually, you can like, it's basically reverse currents.
Yeah.
So the physics behind like everything is reverse. So it'll reduce like, effectively reduce the currents. Like it is an opposite direction of like the primary currents. I think that's probably the best analogy you can potentially use. But I'm not sure, like, is that really worthwhile to go in that much detail? That I'm not quite sure. Probably better like work with higher level, like showing this poor like stroke diagram, like here's the physics, and you can write that as a linear equation. I think that's probably enough, like a disk style.
Okay. Well, I will take a crack at it and send it for feedback. Perfect. Thanks, everyone. Does anyone else have comments? I don't want to keep folks. I know we are over a little bit already.
I got one question actually.
Yeah, sure.
Yeah, it's I know we've talked about this before, but the sign convention in SimPEG, Z is up, right?
Yes.
Or down? Up, right? Okay. Because yeah, I got confused. I was looking at the EDI loader because we were having actually Devin, that MT script is awesome. Like that 1D code is pretty cool. But we were having an issue with importing it, and I was looking at the EDI loader, and it didn't say anything about the Z component up or down. It was just replacing the X and the Y. So I was like, oh wait, EDI is Z down. So I didn't see the fix there. So yeah, thanks. I just needed that clarified.
Yeah, I guess I'm writing it, I think, with Z positive down. Pretty sure. I'd have to go and I'd even have to go and look at it, but yeah, I'd have to look at it again. Right now we haven't really leaned one way or another because the standard seems to be Z positive down, but everything in SimPEG we really want to have as being, X easting, Y northing, and Z up. So yeah. I kind of left it and really wanted to deal with that at some point. Okay. Or put a flag that does something.
Just to check it, at least.
Yeah.
Devin, can you remember what the UBC codes are for
yeah,
3D MT? Because I thought we decided on the convention of up for everything.
It's X northing, Y easting, Z positive downward, right-handed coordinate system.
Oh, okay.
That's the industry standard, and that's the same thing that I think GIF tools will do as well. And if you look at the derivations, because it's still in a right-handed coordinate system, a lot of the derivations will work for both. So I think if you are just looking at your ZXY components, it doesn't matter. I'd have to double check that.
Okay, fair enough.
So if you're doing if you're doing a 1D problem and you really only get, you only really need to get that one impedance tensor value because it's just a 1D problem, yeah, and you have ZXY, then I think it ends up being the same. I really would have to check all of this before I commit to anything.
Okay.
But I could take a look.
Yeah, because the apparent chargeability part of it works awesome. It's great. It's the impedance. It seems to be biasing upward or downward when we're trying to run the inversion on some field data. But yeah, I'll just play around with these components here and see. Same with my tipper inversion when I was saying that last time. I think it's just one of the components is off. So yeah.
Yeah, well, I would like to try and merge the 1D the 1D MT stuff into the branch where we're working on 3D MT stuff. Okay. But I guess I'm deciding between that and then there's also trying to do kind of the stitched 1D with the MT code. I want to be able to do that once I've finished with the EM stuff. Okay.
Yeah, I'd say stick with that stitch there and then we can work on merging afterwards. But yeah, I'll send you a notebook with the data that we have that showing what we have with the impedance inversion on the 1D. Whenever you can look at it if you want. It's there.
Sure, you just have like a particular sounding and then you're just running them independently?
Yeah. Yeah.
Okay.
All right, well, thanks everyone. Have a good afternoon and I'm sure we'll be in touch on Slack and next week at Transform.
Yeah. Right.
Starting Friday.
See ya.
Thanks, guys.
See you Friday.
Good afternoon.